for section 6.1, Factors and X-intercepts. In the last section, we talked about factoring polynomials, and that skill will be very important for this section. First, let's start off with the concept of a quadratic function. A quadratic function is one that has an x squared term as its highest exponent term. Something of the form f of x equals ax squared plus bx plus c, where a, b, and c are constants, and a is not equal to 0. Because if a was equal to 0, then we wouldn't have the x squared term. So this is a quadratic function, and quadratic functions come up a lot in the real world. The quadratic function, or the graph of a quadratic function, is always a parabola of some sort. So one example might look something like this. It's always a parabola. And when we're working with parabolas, x-intercepts are very important. These are the points where the graph crosses the x-axis. That's why they're called x-intercepts. And we're often asked to find x-intercepts based on an equation or the graph of a function. So let's talk about how we can do this. First, let's notice that if we're looking at the graph, the x-intercepts, because they cross the x-axis, always occur when y is 0. Along this whole axis, no matter what the x value is, the y value will always be 0. So that's important to know. When we have our equation of our function, we have y equals ax squared plus bx plus c. So if we're looking for the x-intercepts of this function, we're looking for the values of x when y equals 0. So when we're looking for the x-intercepts, we plug in 0 for y. This will give us the place where, or the places where the graph crosses the x-axis. So if we can solve this equation, then we know what our x-intercepts are. This is where our factoring comes in. But first, let me introduce a concept known as the zero factor principle. It says that the product of two factors equals 0 if and only if one or both of those factors equals 0. So in symbols, this is how it looks. We have something like a times b, and this equals 0. We know this can happen if and only if either a is 0 or b is 0, or both. Right? If neither a nor b is 0, then there's no way that a times b could be 0. So this becomes important when we're solving for x-intercepts. If we look back at our equation of our function, this is what is known as standard form. So if we have 0 equals ax squared plus bx plus c, this is a quadratic function in standard form. And we know now, based on the last section, how to get it into factored form. this would look something like a times x minus some number r1 times x minus some number r2. This is called factored form. So if we can get our quadratic function into factored form, we can use the zero factor principle to solve for our x-intercepts. So notice that we have three terms being multiplied together. We have a times x minus r1 times x minus r2. And we already know that a is not 0, because otherwise we wouldn't have a quadratic function in the first place. We need that x squared term to even get here. So we already know that a is not equal to 0. That leaves x minus r1 and x minus r2. And we know that this whole thing, this whole product, equals 0. So according to the zero factor principle, this says that x minus r1 is 0, or x minus r2 is 0, or both. So now we have some linear equations that we can easily solve. If we say, let's solve this first one, x minus r1 equals 0, we know that this results in x equal to r1. Or in the second case, we have x minus r2 equals 0. We add r2 to both sides and get that x equals r2. So in both of these cases, x equals r1 and x equals r2, if we plug those in to our function, either one of these would result in the whole thing being 0, right? Let's say we pick x equals r1. Then we have a times r1 minus r1 times r1 minus r2, and this is a times 0 times r1 minus r2. So anything times 0 is just 0. So if we're looking at the place on the graph where x equals r1, then we know that the graph will have to cross the x-axis at that point. So if I draw the graph and I'm looking at my parabola, we know that r1 is a place where the graph crosses the x-axis. And likewise with r2, if we plugged in x equals r2, we would get a similar result. We get a times r1, or r2 minus r1 times r2 minus r2, and this would be a times r2 minus r1 times 0, and again, anything times 0 is 0. So again, we get that our function at this point, x equals r2, is 0, so y is 0 at this point. So our graph crosses the x-axis at r2. So once we get our function into factored form and we set it equal to 0, we can use the zero factor principle to solve for our x-intercepts. This is the idea of this section. Make sure you do the reading on Perusall to see more details and more examples of this. And if you have any questions, bring them to class or office hours.